Hello everyone, let's learn about torque today. So it is denoted by tau, which is the cross product of the r vector and f vector. So r vector is the position vector of force relative to a fixed point. And if you take the magnitude of the torque, so it will give you rf sin theta, which is a standard form of a cross product between two vectors. So this is for the reference. And in the figure, so this is the pivot, which is a fixed point, and a force is applied, and just draw a straight line from this fixed point to the force like this. So this is your r vector, and the angle between this r vector and force is phi. It is given in the question. So the magnitude of the torque is r f sin phi. So here the phi is the angle between this r vector and the f vector here. You can see. Let's solve the same problem using another method. So here we break this force into component forms. So this one will be F cos phi and this will be F sin phi. So this is the pivot which is a fixed point. Now draw a straight line from the fixed point to the force. So this is your R vector. Now you can see this R vector and this F cos phi vector, they are in the same line. So the perpendicular distance is 0 and the angle is 0, so the torque is 0. Now coming to the second component, that is f sin phi. So you can see this f sin phi making an angle 90 degree with the r vector. So this is the perpendicular distance, that is the r, angle is 90 degree. So torque is r f sin phi, which we have derived in the first method. So they are basically the same. Now what is the meaning of this perpendicular distance? Let's suppose this is my fixed point and my force is applying in this way. So I draw such a line that will make 90 degree with the force. Let's say this is force. So this will be your r vector. Now in this case, what will be the distance? You can see this force passing through the fixed point. So your perpendicular distance, that is r perpendicular, is basically 0. Let's check out this example. So this is a fixed point here and the force is this one and this is the r vector, and if you see the angle between this r and f is this one, not theta. Remember this thing. So this is 180 minus theta. Okay, so your torque equal to r into f into sine 180 minus theta. Remember this thing. So this r vector, draw a line from this fixed point to the force. So this is your r vector. And for numerical analysis, here you can see, so this is your fixed point and here is the force. Just draw a line straight to the force. So this is your r vector. And you look at, there is some angle is given, but the r vector and the force vector. So this one will be 90 minus 20, that is 70 degree. Remember this thing. So here theta equal to 70 degree. Now you calculate the torque. Torque equal to R into F into sine 70 degree. So R is given 0.75, this one, and force is given 240 into sine 70. So when you calculate it, you will get some value. So let's calculate 0.75 into 240 into sine 70. So this is equal to 169.14. And the unit of this torque is R into F. So this is meter into Newton. So we write like Newton into meter. Okay guys, let's solve this example using both the methods, method 1 and method 2. So now it is given that theta equal to 30 degree. So in the method 1, torque equal to R F sine 180 minus 30, because you draw a perpendicular line from the fixed point to the force. So this is R vector. So how much this is 180 minus 30. So and it is R into F into sine 180 minus 30 degrees how much? Sine 180 minus 30. So it is half. So 0.5. So this is method 1. Let R and F like this. We are not putting any values. Now for the method 2, we break this force into the component form. So now here this will be your F sine theta, and here it will be F cos theta, and the torque due to this F cos theta term is 0 because this fixed point and this F cos theta are in the same line. So let's write torque due to F cos theta equal to 0, but torque due to F sine theta will be R into F sine theta. That's it. So R into F into sine 30 equal to R into F into 0.5. You see, in both the methods, let's say tau 1 and we denote this as tau 2, so we get the same result.